Assalamualaikum. Today, I want to explain you on analog modulation. Okay, I'm saying Sham. Okay, so basically, in this chapter, you will learn on amplitude modulation, introduction, principle of amplitude modulation, amplitude modulation transmission technique, and also comparison. Okay, 2.2 frequency modulation. Next slide. Okay. Now, basically, in this chapter, you will learn of define the AM concept. What is the AM concept? Means where it used, the application, and then you know about the signal, how it look like, and so on. Okay, now, and then you will learn on calculate the AM voltage distribution, modulation index, voltage, power, and power distribution analysis. And then, point number three, you go calculate and draw AM. Okay, amplitude modulation in time and frequency domain. Okay, now basically in communication system you got continuous wave. Continuous wave means in sinusoidal. Negative wave means in 01010101 in beat. Okay, now in continuous wave you got amplitude modulation and also angle modulation. Okay, under angle modulation you got frequency modulation and phase modulation. Okay, digital wave you got analog pulse modulation and digital pulse modulation. Okay. Now, in amplitude modulation, basically this is a basic review of the modulation, where inside here we got the modulation process, or another term we call this thing we call as modulator. Okay, in modulator, what is the function of modulator? Modulator combine the baseband signal or information signal with carrier, and then combine and then transmit. In this case, we are using AM modulator. Okay. So basically, this is the signal of the AMC signal. Okay, this is the carrier signal, modulating signal. It means information signal, and also this is the output, the AM signal, how it look like. Okay, now here you see something like this one. This signal become narrow. This one become wide. In order for you to modulate the signal, the carrier must be higher. This is means when you see wide, the signal become narrow, so the frequency become higher. This one frequency less. So in amplitude modulation, FC bigger than FM, and also for modulation index, your VC must higher than VM. Okay. So the relationship between VC and VM, you can in terms of modulation index. Okay, modulation index is the ratio between carrier and modulating wave. So now, what is the modulation? Modulation is the process of placing the message signal over some carrier. Means you combine information with carrier signal. Okay, demodulation. What is the demodulation? Reverse process. Okay, of modulation. Okay, why we need modulation? Because normal signal are not in the form that's suitable for transmission. For example, if you talk normal signal, your voice, if you cannot, for example, transmit your voice from here for 100 km without you using any carrier signal. Okay, you just maybe for a short distance. Okay, so now time for modulation. We got analog modulation. Okay, analog modulation means AM, FM, and PM. Okay, for digital modulation, we deal with PCM, pulse code modulation, and then keying modulation under ASK, FSK, and PSK. Okay, analog modulation. Okay, the definition, analog modulation, changing the amplitude produce amplitude modulation signal, changing the frequency produce frequency modulation, changing the phase produce phase modulation signal. Okay, so so right now, principle of amplitude modulation, you got to input. To input first, a single one. To input means your information signal. This one high frequency for carrier signal, low frequency for information signal. And then you combine in the modulator. After you combine modulator, we got we generate for transmission using AM technique. So produce AM envelope. What is the AM envelope? An envelope like this. So this is the AM envelope. Okay. So now this is the principle of AM. This is information signal represented by VM. Sometimes V input. Okay, and then VC and also FC. This one FM. This one envelope. okay, the AM signal how it look like. Okay, now, so where we use the amplitude modulation? Okay, application sometimes we use in radio broadcasting, AM mode, TV picture and fixed mile transmission. Okay, frequency range 535 kHz to 1600 kHz. Bandwidth 10 kHz. Okay, this is the principle of amplitude modulation. The modulating signal modulates amplitude, okay, frequency of phase of the carrier according to its variation of the amplitude. Okay, now, so this is a mathematical representation. Okay, now see here. This one is E, M. Okay, this one is C. Frequency. This one sinusoidal signal for amplitude for the information signal. This one carrier signal, and this one modulated signal, AM modulated signal, how it look like. Don't worry, we'll recap on the next slide. Okay, so basically mathematical expression, VM, sometimes they put VMT. Don't worry, I'll give you in exercise. Sometimes I use this formula, this symbol. Sometimes I'm using VMT equals to EM sine omega MT, means this one information signal, omega M equals to 2 pi f MT. How about EC? Equals to, in term of time, means VCT, in term of T, EC sine omega CT. Omega C equals to 2 pi f C. Okay, don't worry, I will recap back. So, when you apply this formula, you got EAM equals to EC plus EM sine omega MT sine omega CT. Don't worry, next class I will show you the derivation for this mathematical formula. Okay, this one introductory class. Okay, so basically in AM envelope, you got carrier signal, modulating signal, and the modulated wave. Okay, now this is the first term you must know. Modulation index. Modulation index VM over VC. Don't make mistake. Okay. Now, so this is a mathematical representation of the signal. Don't worry. Next class, I will show you the mathematical expression I will derive for you so that you will understand how the signal look like. Okay. Now, basically, this derivation we want to show you in terms of other analysis. Modulation index. Also, we can in another term of modulation index beside VM over VC is Emax minus Emean, Emax plus Emean. Okay. Okay, now we go to this one is the time domain. Okay, now we go to frequency domain. Okay, why we need to study frequency domain? Okay, in frequency domain, you can get the value of bandwidth, you can find the power transmit, okay, power at upper sideband, power at lower sideband, okay, and then the voltage here, okay, for power analysis. Okay, normally upper sideband, okay, for frequency for upper sideband, FC plus FM. Lower sideband FC minus FM. Okay, so this is the formula. Play around, don't worry. So we'll show you. Okay, but this thing actually we want to show you in the representation in frequency domain. Okay, this one on FC, this one on lower sideband, this one on upper sideband. This representation. Okay, also can represent in mathematical equation. Okay, so basically, what is this? Actually, this one in terms of voltage, voltage VC. This one V upper sideband. This one V lower sideband. Okay, in between this one to from here to here is bandwidth. Okay, another mathematical form. If you don't want F upper sideband minus F lower sideband, it can be bandwidth equals to 2F FM. Okay, another bandwidth for AM to FM or upper sideband minus F lower sideband. Okay, now, so this is an example. Okay, normally, so already told you, VC should higher than VM. Okay, so what happened here? M equals to modulation index become EM divided by EM divided by EC, 40 divided by 50, 0.8. Okay, this one modulation index. If in percentage of modulation, you times 100, you got 80%. Okay, now, so basically, you can see this formula. Okay, quite direct. Insert the formula. Okay, this one is we give the LC oscillator the question. You find using the formula that you already learned before. Okay, so F upper sideband, you direct. Actually, it's the direct formula. Okay. Now, Modulation index and percentage modulation, as what I mentioned before, M equals to Vm over Vc. The big M is percentage of modulation. Okay, so this is the signal how it look like. Okay, Vmax. Vmax mean Vc plus Vm. Okay, from here to here Em. This one positive Vmax, and then here Vmax, and then here negative Vmax. Don't worry, I'll show you in the next class how to derive. But you must know this one is in terms of mathematical representation of the signal, AM signal. Okay, from here, okay, you can do analysis. Okay, EM you can get from Vmax and Vmin means sometimes in amplitude modulation, we can give you the signal and then you do analysis for frequency domain and time domain. Okay, this is basically the formula you must understand. Don't worry, I give you tutorial and so on. You will understand. Okay. Okay. Okay, this is over modulation. Over the modulation, when modulation index greater than 1 means your VM bigger than VC, you got over modulation. Actually, over modulation is not good. Okay, so this is the AM voltage distribution. Okay, okay. So from here, this is another term. This is another mathematical formula to show amplitude modulation. Modulation equals to Vc plus Vm sine omega mt sine omega ct. Okay. From here, we can show you in term of upper sideband carrier part, upper sideband and lower sideband and upper sideband. Okay, voltage distribution. Okay, this is if you are the average power dissipated in a load by an modulated carrier is equal to the RMS carrier voltage. Remember, if you are using RMS carrier voltage, you must use the formula PC equals to C squared over 2 RR. Sometimes 50 ohm, depend on the question. Sometimes 75 ohm. Okay, now remember, normally we in frequency domain we start to tend to make an analysis of power transmit. Okay, the total power PT distribution, sometimes distribution sometimes we call as power total. Okay, so PT equals to PC plus M squared. This is modulation index. PC divided by 2. Okay, P upper sideband, see here, upper sideband is lower sideband and squared PC over 4 power. So the total power PC plus P upper sideband plus P lower sideband. Remember this thing, because we got in time domain we got power carrier, power upper sideband, power lower sideband. Okay. So this is the formula. Don't worry, when I give you example, you will understand. Okay, basically, for example, like this formula, audio. Sometimes we give you VA. Okay, we give you tan sine 2 pi omega 2 pi 500t. So here is F omega what? This is audio, right? This is carrier. So from here, what is this? Signal for carrier, signal for our audio. So make analysis, you extract. In front of here is what? Audio V, M, right? VA, this one F, A, this one VC, and then this one FC. Again, you straight, apply the formula, you got this answer. Okay, so this is basically the direct formula. Don't worry if you don't understand after this, I will give you tutorial. Thank you, class.